We are going to start chapter 3 tonight. This is one of my favorite chapters probably in the book, and I think it's one that y'all will enjoy too, as crazy as that might sound. But first thing we need to do is define a few words and learn how to identify these words in a diagram. So the first one is parallel lines. You probably already know what parallel lines. They're two lines that don't touch, right? Well, the exact definition of those are coplanar lines that do not intersect. Okay, so two lines that are on the same plane, that's what it means to be coplanar, that do not intersect. We also have some notation for parallel. That is the symbol of just two standing up lines. That means parallel. So for instance, we could say that A is parallel to B. That's how you would read that notation. So let's look at our picture that we have over here. Let's identify some parallel lines in this picture. So let's look at the line, first of all, AD. What line would AD be parallel to in this picture? Well, we need a line that is coplanar and does not intersect AD. So that would be BC. They are both on that yellow plane and they don't touch. So we could say AD is parallel to BC. And we could also say, if you look down here at EH, they are coplanar, they're on that side plane, and they also don't touch. So we could also say that AD is parallel to EH. All right, so that's what it means for lines to be parallel. They are on the same plane and they don't touch. Now we're going to look at skew lines. Skew lines work a little bit differently. Skew lines are non-coplanar lines that do not intersect. Non-coplanar lines that don't intersect. We have no symbolism for skew, you just have to write it out. So for example, some skew lines, and these are a little bit harder to identify. Let's look at AD again, the same line that we just looked at last time. So we're going to try to find a line that is skew with AD. Okay, so it needs to be not on the same plane, but it doesn't touch it. So an example of that would be BF. See how BF is not on the same plane, it's not even going in the same direction as AD, but it also is never going to touch it. So we can say that AD is skew with BF, or to BF. They are non-coplanar and they do not intersect anywhere. It would also be skew with CG. Okay. Let's look at a different one. It would also be skew with EF. So EF goes this way, and AD goes the other way. Those are not going to touch, and they are non-coplanar. Those are our skew lines. Okay. So the last thing we're going to look at are parallel planes. Parallel planes are simply planes that do not intersect. Okay, planes that do not intersect. All right, so any planes that don't touch are parallel. We're using the same notation as parallel lines, the two standing up lines. Okay, so for instance, in our example, the two yellow planes are parallel planes. They are never going to touch each other. So remember, we name a plane with 3 points on that plane. So we can say that plane ABC is parallel to plane, the other yellow one, which is EFG. Remember, you can use any of the 4 points on the plane however you'd like to name those. All right. So those are parallel lines, skew lines, and parallel planes. Let's go a little deeper and talk about a transversal real quick, which is what we're going to be looking at a lot today. So a transversal is simply a line that intersects two or more coplanar lines. So a line that intersects two or more coplanar lines. So line T here is a transversal. Okay? Because it intersects line L and M. So it intersects two coplanar lines. Okay? When you cut two lines with a transversal, it creates some really special angles, which is what we're going to talk about next. It's important to note that everything outside the two lines that are intersected is called the exterior of those lines. Everything inside those two lines that intersect is called the interior of those two lines. That is important. So now we're going to look at these special angles. And what I would do if I were you on your paper, since you only have one picture, is I would use colored pencils or markers or pens to kind of shade in these angles so you can identify the relationships. Okay? So alternate interior angles are non-adjacent, so they're not beside each other. Interior angles, so they're inside the lines, that lie on opposite sides of the transversal. Okay, so the really important part is that they're interior and they're on opposite sides of the transversal. Okay, so for example, I'm going to shade in red some examples of alternate interior angles. So for example, 7 and 3 are alternate interior. You can see that they lie on different sides of transversal R, and they are interior, the two lines. So for example, 7 and 3. Okay. There are one more pair of alternate interior angles here. That would be angle 2 and angle 6. Those are also a pair of alternate interior. Okay. They are on opposite sides of the transversal and interior of the lines. All right, the next type of angle we're going to look at are same side interior. These are also called in some books consecutive interior. Same side interior are exactly what they sound like. They are interior angles on the same side of the transversal. So alternate were on different sides, same side interior are on the same side. Okay, so some examples of those. I'm going to do those in blue. That would be 2 paired with 3. Those are on the same side of our transversal R, and they are interior. So for example, angle 2 and angle 3. All right, another example of same side interior would be 7 and 6. 7 and 6. Those are on the same side of our transversal R and interior. Okay. The next type of angle we are going to look at are corresponding. Corresponding are a little more difficult to explain, but once you get the hang of them, they'll be easy to identify. So corresponding are on the same side of the transversal, and in corresponding positions. And by corresponding positions, all that really means is if I were to pick up line N and put it on top of line M, which one would be in the same position as, for instance, angle 6? Okay, so I am going to shade those in, we'll do orange. So for example, 6 would correspond with 8. They are on the same side of transversal R. They are in corresponding position. So 6 pairs with 8, which means 3 has to pair with 1. Likewise, we could say that 2 corresponds with 4. And finally, 7 corresponds with 5. So this is the only one that we have 4 pairs of. The other ones we only have 2 pairs. So they are on the same side of our transversal and in corresponding positions. So again, that would be like 8 and 6. Okay. The last type we're going to look at are alternate exterior. These are similar to alternate interior, except for they are exterior, our lines. Okay. So a good definition for those would be non-adjacent, exterior angles, that lie on opposite sides of the transversal. Okay, and an example of those, we'll do those in purple, would be, for instance, 1, it is exterior, and then 5, it is exterior, and they are on opposite sides of our transversal. And then the last pair would be 8 and 4. Okay, so those are on opposite sides of our transversal, and they are exterior, the 2 lines. So hopefully that those definitions, you can see the difference between each one. What we'll work on tomorrow is coming into class and really just identifying parts of those. So the last thing I want you to do, I want you to try out a few problems with these. So go ahead and pause the video, see if you can come up with something for each of these, and then when you unpause it, I'll put some answers up. Okay, so there are the answers to those problems. 4, 1, 2, and 3. You may have had different answers. There were lots of possible choices. So we will look at those more in detail tomorrow. So come to class tomorrow ready to work.